This is Nova. Here is the signal. A man who had been blind for almost 40 years sat in a lab, put on a pair of special goggles, and was asked to find a dark object on a white table. He had been told his entire adult life that what was broken in his eyes was permanent, that lost sight does not come back. And then he reached out, slowly, and touched it. He could see its outline. Not perfectly, not in color, not the way you see this screen. But after 4 decades of darkness, the impossible had quietly become an engineering result. That single moment is the clearest signal I can give you that one of medicine's oldest one-way doors is starting to open. To understand why this is so strange, you have to understand what blindness usually is. Roughly 40 million people worldwide are blind, and many millions more are losing their sight. But blindness isn't one thing, it's a whole family of very different failures along a single chain. Light enters your eye, lands on the retina at the back, where tiny cells convert it into electrical signals, and those signals travel down the optic nerve into the brain, which assembles them into the picture you experience. Break that chain anywhere, the light-sensing cells, the wiring, the brain region, and you go blind. And here is the first hard truth. There will never be one cure for blindness, because there is no single disease. What's arriving instead is a toolkit with a different tool aimed at each broken link. Start with the most science fiction sounding tool, the one that gave that man his outline back. In many forms of blindness, the eye's light-sensing cells die, but the deeper wiring, the cells that carry signals to the brain, survives just sitting there with nothing to talk to. So scientists asked a wild question. What if we could teach those surviving cells to sense light themselves? The answer came from an unlikely place, pond algae. Certain algae make proteins that react to light. It's how they steer toward the sun. Using gene therapy, researchers delivered the instructions for one of those algae proteins into the man's surviving retinal cells. His own eye began manufacturing a light sensor borrowed from a plant. The cells that were never meant to see suddenly could. This field is called optogenetics, and the first time I read that a human being saw using a protein from algae, I had to put the paper down. We are no longer just repairing the body's hardware. We are installing new parts from across the tree of life. Now the second tool, and this one isn't a future promise, it's already approved and sitting in clinics. Some forms of blindness are caused by a single typo in a person's DNA. One specific gene broken that the retina needs to survive. For one such inherited blindness, doctors can now inject a corrected copy of that gene directly into the eye. A harmless virus, emptied of its own genes, is used as a delivery truck. It carries the working instructions into the retinal cells, which start following the correct recipe. Children who were on a path to total darkness have kept their sight. Some have gained the ability to walk through a dimly lit room for the first time. Here's what I want you to sit with. That is a one-time treatment that rewrites a flaw in the body's source code. We have moved from managing blindness to editing the instruction that caused it. But let me push back on my own optimism because the hype machine will not. Every one of these tools is narrow. The algae protein approach gives shapes and contrast, not faces or fine print. Useful, life-changing for navigation, but not, and then he read the newspaper. The gene correction therapy only works for the specific genetic typo it was designed for, a tiny slice of all blindness, and it costs a staggering amount, among the most expensive medicines ever priced. And both depend on something surviving in the eye to work with. If the entire retina is gone, if the optic nerve is severed, these tools have nothing to grab onto. The honest signal isn't blindness is cured. It's for the first time, specific causes of blindness are becoming targets we can hit, and the list of hittable targets is growing every year. So what about the cases where the eye itself is beyond saving? This is where the most radical idea comes in, and it abandons the eye completely. If the problem is that no signal is reaching the brain, then why not skip the broken eye and feed the signal directly to the brain's vision center? Researchers have implanted grids of tiny electrodes onto the visual cortex and connected them to a camera mounted on a pair of glasses. The camera captures the world. A computer translates it into patterns of electrical pulses, and those pulses are delivered straight to the brain, which perceives them as spots of light. Volunteers have used systems like this to make out crude letters and the edges of objects, generated entirely by a camera, with their eyes left out of the loop. It is bionic sight in the truest sense. the eye replaced by hardware, the brain doing the rest. And that points at the deepest part of the signal, the part the headlines miss. As these tools improve, seeing stops being something only eyes can do. A camera-to-brain system isn't limited to the kind of light human eyes evolved to catch. In principle, the same wiring could one day pipe in infrared or a zoomed-in view, or information that isn't light at all. I don't say that to promise it soon. It's genuinely hard, and the resolution today is crude. I say it because it reframes the whole project. We started out trying to restore the eyes nature gave us. We may end up redefining what a sense even is. The same path that gives sight back to a blind person is, quietly, the path toward senses no human has ever had. Here is the honest near future, stripped of the fantasy. We are not about to hand every blind person a perfect pair of working eyes. What's genuinely arriving is a growing menu of repairs, each matched to a specific kind of failure. Light sensors borrowed from algae for dead retinal cells, gene corrections for inherited typos, electrode arrays for eyes that can't be saved at all. For more and more people, blindness is shifting from a permanent sentence to a problem with a possible address, a thing engineers can aim at. And every one of these tools is in its earliest, clumsiest version. The first telephones were almost useless too. Step back and the meaning comes into focus. For all of human history, lost sight was simply gone. One of those losses you learn to live around, never undo. We are now, imperfectly and one cause at a time, learning to argue with that. We can teach a cell to see with a borrowed protein. We can correct the typo that stole a child's vision. We can route the world around a ruined eye and into the brain itself. None of it is finished. All of it would have looked like magic a single lifetime ago. The door marked permanent is, for the first time, beginning to swing. So the question isn't really, will we cure blindness? The honest answer is, not all of it, not at once, not perfectly, but more of it every year, one broken link at a time. The deeper question is what happens to all of us once sight becomes something we can install, repair, and maybe upgrade, and whether the senses you were born with stay the only ones you'll ever have. This was Nova. Subscribe to keep receiving the signal.